interesting, I can delete my file. This is
All right. You're welcome back to my YouTube channel. I'm Hypam. This is lesson 4 of physical chemistry, and our today's lesson, we are going to be looking at the calculations that we can make in buffer solutions, and we are going to begin our calculations using examples of acidic buffers. So we are going to look at the calculations of acidic buffers. This is a very interesting area where we expect most of the questions or some questions to come, and allow me immediately switch to examples. Example number 1 is a question, and the question is 3.28 grams of sodium ethanoate were dissolved in 1 liter of 0.01 molar ethanoic acid. Ethanoic acid solution. Full stop. Calculate the pH. The question is calculate the pH of the resulting solution. Calculate the pH of the resulting solution. And we have been given pKa of the acid as 4.735. This is quite interesting. The question is 3.28 grams of sodium ethanoate. We need figures and solutions, basically. 3.28 grams of sodium ethanoate were dissolved in 1 liter of 0.01 ethanoic acid solution. Calculate the pH. Now, before you overthink about the pH, first know what type of solution is this. We are given sodium ethanoate and ethanoic acid. And as a reminder, sodium ethanoate and ethanoic acid, they constitute to an acidic buffer. Reason, ethanoic acid is a weak acid and sodium ethanoate is the salt. All right, it's a salt of a weak acid. And therefore, if we are to calculate this, we shall substitute in our equation. All right, we are going to substitute in our equation of Henderson-Ashebach that we derived in our previous video. So what you have to do here, first and foremost, you need to first quote that formula. We said that pH is equals to pKa plus logarithm of the concentration of a salt, and the salt is sodium ethanoate out of the concentration of an acid. Concentration of an acid, our acid is ethanoic acid. Now, ask yourself, do I have all these given? Not really. I have been given pKa, so we shall substitute pKa. Here we are given pKa as 4.735. We are given concentration 0.01 molar ethanoic acid. So we are also given the concentration of ethanoic acid and it has these square brackets represent concentration, and it is 0.01 molar. Again, we are given concentration of sodium ethanoate, but in grams. If you read the question very well, they are saying that 3.28 grams of sodium ethanoate were dissolved in 1 liter of 0.01 molar. So now they were dissolved in 1 liter. So these are grams per liter. After being dissolved, they were made to 1,000. And what does it mean? It means that we need to get the moles of sodium ethanoate per liter. Since we are having grams in a liter, we can get moles in a liter, and that will be our concentration. And given mass, when we need moles, we really need to first get the molar mass of sodium ethanoate. So we shall say that molar mass of sodium ethanoate molar mass of sodium ethanoate will be equaling to carbon is 12 plus hydrogen is 1, but times 3 atoms of hydrogen, plus carbon is 12, plus oxygen is 2 times, so we shall say 16 times 2, then plus sodium, which is 23. This one will give us the molar masses. This is 12, plus 3, that is 15, plus 12, that is 27, plus this, that is 60 plus 32. We are going to have our molar mass as 82. Yes, 12, 15, 27, 50, 82 grams. Now, after getting the molar mass, after getting the molar mass of this, after getting the molar mass, we are going to look for the moles of sodium ethanoate in 1 liter of solution. Another one will be equaling to, we get mass, the mass of sodium ethanoate, which has been given as 3.28 out of the molar mass, which is 82. So this one will give us 0.04 molar. Now, we are now having concentration also of sodium ethanoate as 0.04 molar. Come back to your equation and substitute for whatever you have gotten. So we shall have that our pH is going to be equaling to pKa has been given direct, so we have 4.735 plus logarithm concentration of sodium ethanoate has been given as 0.04 out of concentration of ethanoic acid has been given as 0.01. So this is 4.735 plus logarithm of this. When you put on your calculator, this is the logarithm of 0.04 out of 0.01. This one will give you 0.602. And this one will give you an answer 4.735 plus 0.602. From my calculator, you get 5.34 as the pH of the resulting solution. And the question is as simple as that. Now, I'm going to do you another second example, and we see how best it can be attempted. So this one, I'm going to rub it off. I write another second example, and we see how it can be done. As you can see, since the pH is this, it really shows you that the solution is acidic. Sodium ethanoate and ethanoic acid constitute an acidic buffer that we looked at when we were looking at our first lesson. Now, let me delete this, and then I do you the second example, and we see. The second example says, calculate the mass of sodium ethanoate that must be dissolved in 1 liter of ethanoic acid, all right, of concentration 0.085 moles per decimeter cubed to form a solution of pH 5.45 if the Ka of ethanoic acid is 1.8 exponent -5 moles per decimeter cubed. All right, calculate now. They need the mass of sodium ethanoate that must be dissolved in 1 liter of ethanoic acid of concentration 0.085 to form a solution of pH 5.45. If the Ka is this one clearly, by looking at the solutions given, we are given sodium ethanoate and ethanoic acid. And what does it mean? Still, this is an acidic buffer. Sodium ethanoate, ethanoic acid. Ethanoic acid is a weak acid, and sodium ethanoate is its salt. So here, let me say what we are given. We are given pH this time round as 5.45. All right. We are given concentration of ethanoic acid as 0.085. We are also given the Ka of ethanoic acid as 1.8 to the exponent -5 moles per decimeter cubed. What does it imply? Being an acidic buffer, the equation still holds that pH is equals to pKa plus logarithm to the base 10, of course, of the concentration of a salt. Our salt is sodium ethanoate out of the concentration of the acid, which is ethanoic acid. All right. Substitute. pH has been given as 5.45. pKa. To get pKa, you take the negative logarithm to base 10 of the Ka value, which is 1.8 times 10 to the power negative 5. Plus concentration of sodium ethanoate is not given. Therefore, we shall keep it unknown. Out of the concentration of ethanoic acid, the concentration of ethanoic acid. Actually, that concentration of ethanoic acid, I have cross-checked with my question. I've cross-checked with my question. It has been given as 0.1. It has been given as 0.1. So let's make a simple editing here so that we don't get parallel values. As 0.1. And that is what I am having. Looking at this, this is going to be, you take the negative logarithm of this value, you're going to get 5.45 is equals to negative logarithm of this value is giving you 4.745 plus, here we keep with our logarithm, so plus logarithm, the unknown concentration out of 0.1. The other step is to bring this value this side, and when you do that, when you bring it this side, you will subtract it from this. So you're going to have our logarithm of the concentration of sodium ethanoate out of 0.1 is equals to, when you subtract, you're going to get 0.705. And after getting this, now this logarithm is for the whole of this value. And what does it imply? If the logarithm is for the whole of this and you're dividing, it means that the safest way is to subtract. So we are going to say logarithm of the concentration of sodium ethanoate minus logarithm of 0.1 shall be equal to 0.705. Now, this one is unknown, and therefore we are going to keep it as logarithm to the concentration of sodium ethanoate plus, this one will make it plus 1, it will be positive 1. The negative logarithm of 0.1 is positive 1, and this is 0.705. Now, when you take a 1 this side, you're going to keep it at 0, rather the logarithm of concentration of sodium ethanoate is equals to, when you subtract a 1, you're going to have negative 0.295. But we are interested in the concentration of sodium ethanoate first, so we shall take the negative anti-logarithm. And since this is logarithm to base 10, however, it is a natural base, that's why I've not been showing it, but it is automatic 10. If the base is not shown, then simply know that we are dealing with base 10. So the concentration of sodium ethanoate would be equaling to, if I take the anti-logarithm, one also can say 0.295. If you make the concentration the subject of this equation, of this formula, it will be 10 power this. Now, From there, you're going to find out that the concentration of your sodium ethanoate is equals to, when you take this 10 to the power negative 0.295, you're going to get your concentration as 0.507 molar. But the question is, calculate the mass of sodium ethanoate that must be dissolved in 1 liter. So they need mass in 1 liter or mass per liter. So what are we going to do? We are going, since we have the moles or the concentration, we are going to get the molar mass. And with the molar mass, we can easily convert the molarity or the concentration from moles to grams. So the molar mass of sodium ethanoate is going to be equaling to carbon is 12 plus hydrogen is 1 times 3 plus carbon 12 plus oxygen is 16 times 2, then plus sodium, which is 23. When you compute this, this is 12, 15 plus 12, that is 27 plus this is 50 plus 32, that is 82. So you're having 82 grams. Now, we can, as well, after getting the moles, we can get mass of sodium ethanoate in 1 liter, which will be the molar mass times the molarity 0.507, and this one is going to give you 41.57 grams. Our viewers, that is how this calculation was supposed to be done, and I wish that you subscribe to our YouTube channel, Hypand Chiwafu Academic Channel. You like, you share, and you comment in case of anything. We wish you the best. Stay blessed. More examples and more other questions are coming your way. Thank you.